Welcome to the Real Python Podcast. This is episode 15. Have you wanted to learn regular expressions in Python, but don't know where to start? Or maybe you've stumbled into the dreaded pink setting with copy warning in Pandas. This week on the show, David Amos returns from the Real Python team to discuss a two-part series on Regex and Python. We also talk about another article about views versus copies in Pandas and how to avoid that annoying setting with copy warning. David also brings a few other articles and projects from the wider Python community for us to discuss. Every week, David searches for the latest Python news, links, and articles to produce PyCoders Weekly with Dan Bader. PyCoders is a free email newsletter for those interested in Python development. Along with the previously mentioned Real Python articles, we also discuss a few articles from the community about getting machine learning to production, combining Flask and Vue, space science with Python, and the fastest way to flatten a list in Python. All right, let's get started. My name is Christopher Bailey, your host. The Real Python Podcast is a weekly conversation about using Python in the real world. Interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back.
Hey, thanks. Good to be back.
Yeah, so we have a few different articles from Real Python we're going to talk about this week, and then again, some outside ones. And then what I'm kind of excited about is we have a new segment we're going to kind of talk about at the end about projects, which I think will be a lot of fun.
Yeah.
Okay, so I'm going to start it off, and I'll talk about a recent article on Real Python. It's called Setting with Copy Warning in Pandas, and the subtitle is Views versus Copies. What's interesting, this is by Mirko, as part of our Real Python team. I originally had taken this to try to see if I might be able to write an article, and I kind of got stuck, realized I'm not quite as much of an author as I thought, but I had done an outline and had studied it a lot, and I was very interested in it. I think this is something that comes up a lot for people that are getting into data science and using pandas. And I was told at my place of work at the time, when these pink warnings would come up in my Jupyter notebook, I would say, hey, this doesn't look like this is running right, the way that I wrote this. And the guy I was working with was like, well, what does it say? I was like, oh, that's just a warning. Okay, well, I don't think I should be having these all the time. And I think it's something that's not uncommon, this sort of dreaded pink box that, means that you may have an issue or you may not have an issue, depending on the situation. And so it was really interesting to kind of do the research and learn about it. And it really has a lot to do with how you are approaching like filtering and then sort of assigning things inside of pandas. And what can happen is this thing called chained assignment. And it's like, warns you a value is trying to be set on a copy of a slice from a data frame. And then it warns you, maybe you should be using the loc, or however you want to pronounce it. And then a certain way of like sending in these two values or parameters into it instead. What's weird is the chained assignment thing. You may not realize that you're doing it because you might have done it in a couple steps. And so this article goes into depth talking about not only like kind of what's happening behind the scenes, but also the times when that warning is actually really important, because you might have created what's called a view instead of the copy, and the assignment that you were trying to do might have actually not been applied. So you might not even have the correct data inside there, which is really an important reason for the warning. And goes into talking about the special methods that are inside of the NumPy and Pandas library there, dunder get item and dunder set item, and kind of how they work.
Yeah.
And on top of that, what's kind of funny is I've heard people actually, or seen other people say, oh, you can just sort of get past this by going in and turning off that warning. There's actually a way to change how chained assignment works. And they're like, oh, I don't want to be bothered with it. But again, you can't always be guaranteed that it's going to work. And so I definitely don't suggest that. And I think it's a good way to kind of get into it.
Yeah.
And then one other thing that I thought was kind of interesting about it, the other reason that it can happen where you'll have issues with it not actually applying your assignments is because your data frame has a real mix of types of values in it. And pandas will behave slightly differently if, say, all the values in the data frame, say they're all floats or something like that, compared to integers or objects or whatever. And so that kind of behavior will vary, and also the order that you do your assignments in. So I think it's a really, anybody who's in data science or is working with pandas and has at least seen that warning, it's a really good way to kind of get a deep dive on like what's happening and how to get around it and do a little more proper work with pandas inside there.
Yeah, no, that's good. I mean, I think this idea of it's just a warning and I'm just going to shut it off and ignore it is really not the right way to go with these things. I mean, warnings happen for a reason. You should stop and think, why did this occur?
Yeah.
And can I safely ignore it based on understanding what that warning actually means, as opposed to just wanting to shut it up so that it's not annoying you anymore. Right? So,
exactly.
Yeah, this is a great article.
Yeah. I mean, I've literally seen people turn in a Jupyter notebook and it's, got those warnings all throughout it. And you're like, okay, well, number one,
yeah,
why are you ignoring this and going past it? And so I think it's definitely important to not ignore it.
Yeah, for sure. No, it's a great article.
Cool. So what do you got?
First one I got is an article by a guy named Chris Conlon. It's the fastest way to flatten a list. And this was released on June 5th. So it's a recent article. And he discusses, 6 different methods for flattening a list of lists. So if you have a list that's got several other lists inside of it, then these methods will work. They don't work, say, if you have a list that has maybe just a single value and then a list and then maybe a few more single values and then another list. So like it has to be a list of all lists in order for these methods to work. But he kind of compares these different ways of doing it. So he writes these 6 functions that each do these 6 different methods of flattening a list, and all of them loop over all of the sublists and then add it to or create a new result list, basically, that has the flattened list in it. So that's kind of an important piece of the setup to know how he's going about it. So he's each one creates an empty list called result, loops over the list in the list, and then explores various ways to add those lists or extract them into the result list. Hopefully that makes sense. So he looks at doing, say, okay, I'm going to do result equals result plus, using the plus operator with whatever list is inside my list of lists, or using an augmented assignment where you do result plus equals the list, using the extend method, so result.extend, and then pass the list to extend, or using the append method where you loop over not only each list in your list of lists, but then also you have a nested for loop that loops over each value in those sublists and then appends those values to the list. And then finally using a list comprehension to extract each value from each list in the list of lists. So lots of lists going on there. But there's these 6 different ways. And the question is which one of these is the fastest, and how do they compare to each other? So he doesn't provide any of his timing code. So he doesn't show how he actually came up with any of these values or anything, but he does have a couple of nice looking charts here that show that the slowest one is using the plus operator. So if you have your result list and you're going to do result equals result plus whatever list you want to add into that result list. And that one, if you know how the plus operator works, it's probably not too surprising that that's actually the slowest, because it's creating a whole new list each time. So when you do that result equals result plus list, that original result it's creating a whole new one and assigning it back to the name result. So
yeah, that makes sense.
That's going on. The fastest ones, which might be surprising.
I wanted to guess.
Yeah, guess.
I was hoping it was going to be the comprehension one, but
it is not, actually.
Okay.
The fastest one is using the plus equals operator. And that one is probably surprising because you think, well, plus equals is just sort of syntactic sugar, right? For result equals result plus list. It should be the same thing as result plus equals list. But that plus equals operator, the way it works under the hood, there's some additional optimizations there. And actually, I tested it in a terminal. It does not create a new list.
Okay.
the result list that you're like adding everything to stays the same, has the same memory address.
Yeah.
So
same ID or whatever.
Yeah, so that one is the fastest, although really close second is the extend method. They're kind of it's actually kind of hard to call one a clear winner over the other looking at these charts, but and then the other ones are kind of just in the middle.
Okay.
Just hanging out there, not really.
Not impressing on one way or the other.
Yeah, just they're just there, So yeah, I think most people probably would have assumed like the list comprehension would probably have been fastest as well. But that one, you've got a nested for loop, so you're looping over not only each list in the list of lists, but then also each value in each of those lists. So there's a lot more going on there.
Okay.
So one thing that is not listed in this article is in the iter_tools module, there's a chain function,
okay,
which is used to chain iterables together, which is almost exactly flattening. You can think of it as one application of chain is flattening a list. So if you have a whole bunch of lists and you want to iterate over each item in all of those lists sequentially, you can pass them each as arguments to chain, and then it'll treat them as if it were just one big list of values. So that's not in here, and I didn't do any timing to compare what it's like, but I would kind of expect it to be faster. But I don't know. It'd be interesting to see how that
another experiment
compares to all these. Yeah.
What are examples of like lists of lists? I'm trying to think of like some kind of real world examples that we could put in their head.
A two-dimensional array is a really common example, right? You have like a matrix of numbers.
Like a data frame, sort of, right?
Yeah, sort of like a data frame. A data frame is
right.
Kind of much more complicated than just a list of lists. But yeah, one way in pure Python to represent a matrix would just be to use a list of lists where each list in the list is a row of the matrix.
Right.
Yeah.
Okay. Just want to make sure people can have a good image of that in their head.
Yeah.
The next one I'm going to talk about is from test-driven.io. And it's about combining Flask with the JavaScript framework Vue, which I'm pretty sure that's how it's pronounced, though I've heard it pronounced Vue.
Oh.
But I'm pretty sure it's intended to be like a view of something. And it's by Jace Medlin. So Flask is a really great tool. In fact, I'm pretty excited. I'm going to do an interview with Armin Ronacher coming up shortly.
Cool.
And you should hear that coming in the feed soon. And we'll talk a bit about the 10 years of Flask here.
And what does he have to do with Flask?
He was like mainly the creator of it. He created all the underlying frameworks that are there of sort of combined them all to create, Flask and create this nice lightweight tool.
Cool.
And so this article goes into 3 different ways to sort of combine Flask and Vue. First is using a Jinja template, again, part of Flask. Jinja template is this nice way of kind of inserting chunks of HTML into your Python code to kind of like allow it to kind of go back and forth. And it's a nice templating tool. You actually can see it in other frameworks such as Django. It's popular out there. And I think in that one, you're importing Vue into the actual templating. And then the next couple go into creating a single page application, or abbreviated SPA. And that is where you're sort of separating the two completely. You're saying kind of front end, back end kind of idea.
Mm-hmm.
Whereas Flask is acting a bit more like an API, and Vue is totally running all the front end sort of stuff. And then the last way is using what's called a Flask blueprint, which is a popular way of working with Flask today.
Gotcha.
Serving up Vue from an actual blueprint that you've created in Flask. And it sort of is a little more combined, the two of them in that case. They're kind of working back and forth a little more. And it goes into, how to set them all up. And then what's really nice is get a chance to kind of play with them all. There's a nice repository on GitHub where all the code is, and you can kind of play around, and it goes into the pros and cons of each. And I think, if you're interested in kind of playing around with new front ends and trying out some of this new technology coming from JavaScript, I think it's a nice way to kind of get into it.
Yeah, absolutely. I thought that was a really good overview. And like you mentioned, I really like the way it very clearly, I think there's an architectural diagram for each type, each way of combining these two things. And then it goes into the pros and cons and kind of gives you like, this is when you should really consider using this method of combining them. So yeah, really, if you're interested in using those two technologies, it kind of gives you a really good starting point to just sort of figure out how you're going to approach that and then kind of go from there. So very cool.
Yeah, there's like this little bonus area where if you're concerned about SEO,
oh yeah,
and you're going to be using Vue, and so there's like kind of this other technology kind of underneath there, this thing called, I'm going to guess it's pronounced Nuxt, Nuxt, and how that can kind of optimize things for SEO, which depending on the type of site that you're creating, that might be important.
Right.
Yeah. So what do you got next?
Next, I got another RealPython article, actually series of 2 articles on regular expressions.
Sweet.
And before we move forward, I got to clear the air. And I just got to ask, is it Regex or Regex?
I have, in my travels, always heard it pronounced Regex. But I'm not really a big fighter on the GIF thing either. I've always called it a GIF, so whatever.
No,
so I'm guessing my soft G is following through here with Regex.
it's a funny debate. Although I do have to say, if you're going to call them Regexes, then I ask that you also call them regular expressions, just to be consistent.
Sure.
So, okay.
All right, I will.
Now that that's passed, we can move on. So this is by John Sturtz, who's a prolific RealPython author. He's got a massive series on all sorts of topics in Python. It's really an introduction to the Python language.
Yeah, I did 2 sections of his ongoing stuff there. The one about lists and tuples, and then went into the whole thing with strings and character data. So yeah, I'm totally familiar with his work.
It's good stuff. And so back in April, we released part 1 of the regular expressions mini series. And then just a couple weeks ago on June 3rd, we released part 2. So we've now got which is the last part. So we've now got a complete coverage of regular expressions and the RE or re module in Python. And it's a really cool introduction. I like the way it's structured. The first part starts with just gently introducing you to the re module and how regular expressions work. And it's all using the search function from the re module. So you're not, if you've ever used the re module, there's like a billion functions in it. And it can be kind of intimidating when you first, especially if you're not familiar with regular expressions, just seeing like there's like find and find all and match and search. And it's like,
right.
And then sub. And there's just so many different things. So I really like that he just picks one that's kind of like a very common, something you would use very commonly. And we're just going to stick with that and then kind of gently drop you into the world of regular expressions. So in part 1, he introduces you to the search function, which you pass it a regular expression pattern. Okay, you pass to search a regular expression pattern and also a string that you want to search.
Okay.
And it scans the string for a match for that pattern. If it finds a match, it returns something called a match object. And if it doesn't, then it returns none.
Right.
And he goes into what the match object is. So he gives an example of looking for the string 123 inside of another string. And if it finds a match, it returns this match object. But what is this match object? And he just sort of gently introduces you to it and says, okay, it's got kind of 2 important things in it. It contains a tuple called the span, which is the start and end index of where the match was found. And it's the first match that it finds in the string. And then a string of the actual match of the actual pattern. So that's kind of an overview of what this match object is. It contains this information. He drops into regular expression meta characters, and these are all the different characters like your asterisk and your $sign and the plus sign and the question mark and all the stuff that you use in regular expressions that makes them look really wild and exotic and difficult to understand. Breaks it down real clearly what each one does and how it works. And how you use them in patterns. He also talks about how to do things like searching for groups and things called named groups inside of patterns, how to do matching with flags so that you can ignore the case in your string. So if you are looking for maybe a substring of ABC, then it doesn't matter if it's capital A, lowercase b, capital C, or all lowercase ABC or all uppercase. Just any of those combinations, and also matching across like multiple lines. So being able to sort of ignore like new line characters in there and things like that. So really dives real deep into how regular expressions work, how to build these patterns, how to use flags to get different kinds of results, all using just the search function. So that's part one.
Yeah.
Part two then gives a deeper dive into all the different functions in the remodule. So you get introduced to things.
Okay. So it's diving deeper on the Python side.
Onto the Python side, yeah. So it kind of covers search again real quick, and then it looks at match, one called full match, find all, find iter. It talks about what each of these do and how you use them. There's tons of examples throughout the whole article. It also talks about compiling patterns, which is if you have to do lots of matches with the same pattern, compiling it can get you performance boosts there. That if you don't compile it, you can actually have a negative effect on performance as long as you're doing tons and tons of matches with the same pattern. So it talks about compiling those, and then a deeper dive into what a match object actually is and all of the methods and attributes on those. So it's a really thorough overview. And the thing that I really like about Sturtz's writing is, in one sense, it's sort of like documentation, because it's so thorough. It covers so much of what's there, like you would expect in like the Python docs. But the Python docs, as great as they are, lack a lot of examples and a lot of hand-holding for beginners and people who haven't seen a lot of the stuff. And so John provides that in his articles. So you still get kind of that full gamut of everything is there, but with that really gentle touch from someone who's understands that you may not be initiated into all this yet and are still trying to figure it out. So it's a really good combination of those two worlds.
Yeah, I had to play around with regular expressions a lot at the last job I had in marketing, and it was a really common thing that, I would work with an area where they were doing actual physical mailers, and some people were fine with the idea. Okay, just like hard all caps like names,
Yeah,
and things like that. And a couple of people there were like, that is so ugly. And they just, I think that's like the easy way out for a lot of people,
right.
Style wise. And so I created, a system that would actually, try to properly capitalize names, which is a whole thing in of itself, when you get into like McDougal or, O'Neill,
yeah,
or whatever. And so I had to create this really elaborate regular expression thing to kind of deal with that. Yeah. So I've had some practice and tried to take some techniques from other places, but I think the second half of that tutorial series would probably help me more with all the other different ways of actually using it inside of Python and how they kind of differ from other, styles of regular expressions.
Yeah.
This week, I want to shine a spotlight on another Real Python video course. It's about a topic that will expand the way you and your code can work in Python. It's titled Reading and Writing Files in Python. In the course, Darren Jones takes you through what makes up a file and why that's important in Python, the fundamentals of reading in and writing to files, file paths, and appending to a file, and you'll work through some common scenarios for reading and writing files. I think it's a worthy investment of your time to understand best practices for opening, closing, reading, and writing files in Python. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So my next one it's a series. It's about space science, and it's called Space Science with Python, a sort of a data science tutorial series. It's by Thomas Albin. And it's sort of an ongoing series that Thomas has been working on, where he's taking an open source library and creating a whole set of projects to, do exploration of this set of data from NASA and an organization called NAIF, the Navigation and Ancillary Information Facility. They have these flight projects and research what's called SPICE, which is an observation geometry information system to assist scientists in planning and interpreting scientific observations from space-based instruments aboard robotic planetary spacecraft. So you can think of all these different probes that have been sent out and are tracking comets or doing flybys of different planets, and all the math and geometry that's involved in trying to figure out how to work with that. And of course, all this data is from NASA, so it's public. But what's nice is there's a library called SpicyPy that has basically compiled all of that and created a library inside of Python that you can use. And so his article goes in and has, gosh, it's got like 12 parts, no, 15 parts. And it goes all the way from like just, setting up your environment and, getting the Python wrapper SpicyPy going.
Yeah.
Then it goes into Kepler's first law, goes into sort of the solar system center and talks about Venus, space maps around the sun, goes into like all these different kinds of individual projects. A lot of it is kind of comet based, which is interesting, and exploring this particular comet 67P. I think it's a really kind of neat series. I didn't have a chance to start installing it and play with it a little bit myself, but as I was exploring it, I kind of had a little bit of frustration because it's on Medium. Medium is, kind of a combination of blog platform and sort of tries to not have ads on it. And so when an author marks something with a star on it, it indicates that this is designed to be kind of behind Medium's paywall. And the paywall, unfortunately, if you go there and you check out the article, you can only read, I think, maybe 4 articles a month.
Yeah.
And just doing a little bit of the research on this and kind of bouncing around between the different sections, I used that up right away.
Yeah.
And so I was like, oh no. I was able to do some basic stuff, and maybe some listeners have Medium accounts, and that's cool, but I just want to warn you in advance that is, kind of a thing where you may, if you're interested in diving deep into this specific tutorial, you might need to sign up for a month of Medium, try it out. Otherwise, you can check out a lot of the SPICE information from NASA itself, and I'll include links for that along with the link to the article to go get the information from the NAIF itself. And then the SpicyPy documentation, which is spelled SPICEY and then pi, is available. They have a read the docs documentation site. And on there is actually a really great tutorial also with individual lesson, and it's all indexed out. And that's not behind a paywall or anything. You can kind of check it out. And you're interested in doing some geometry and mathematics and, space-based data science kind of work, I think it's a really kind of neat library to kind of get into. I was joking with you earlier that it reminded me of The Martian and Donald Glover's character, who's doing all the calculations for how to travel and, rescue the person stranded on Mars. So I think that's pretty cool. You're really into space. So I think that might be why you picked this one out, right?
I am, yeah. Yeah, I just thought it was cool that, the guy had written, these like 15 different articles that were going in all these different examples. And it's just really a neat library. And I love that all that stuff is not the Medium articles, but like the data and everything is just open. And anyone can go and play with this stuff. And
yeah,
I just read recently, I forget where, it may have been like Ars Technica or something, that I saw that a citizen astronomer just discovered a new comet.
Wow.
And so, because all this stuff is open, and then now you have these tools like SpicyPy and other Python frameworks for working with like astrophysical data and everything, you have, people that are just working on their laptops at home that are helping make discoveries in space. And it's just really fascinating that stuff is just available to people now. And with Python, it makes it so approachable to get into that kind of stuff. So, one thing I like on the SpicyPy documentation is, like you mentioned, they've got these lessons that are really cool that just kind of walk you through how to use it and everything. But they've also got this Cassini position example. So the Cassini probe was the one that spent a bunch of time around Saturn, taking some of, they're absolutely phenomenal photographs that we have of Saturn now, thanks to Cassini. But it walks you through this example of using the SpicyPy to interpret all the data of like its positional data, and then using matplotlib create a 3D plot of its position between like it's June 20th, 2004 and December 1st, 2005. So you can see like all the different orbits that it made around Saturn and everything. So yeah, super cool example. And again, I just think it's amazing that this kind of stuff is out there and available, and anyone can get their hands on it and start to kind of play around with it and see what they can find and discover. That's really amazing.
Yeah. Yeah. It's a neat time. The internet allows the distribution and availability of the data, and then the open source world helping out to make it usable on all these different platforms, which is really cool. All right. What else you got?
So the last one I got today is from Vicky Boykis, who has written an article called "Getting Machine Learning to Production."
Okay.
And I was really excited to see this. So Vicky is a data scientist, and I'm not actually sure. I don't know if she's a consultant or if she works for a company now. I'm looking at her bio. I've heard her on several other podcasts, and I follow her on Twitter, and I'm always on the lookout for new articles that she's written, because I think she's a really good writer, and she's got a good sense of humor, and it's just always a fun read. And so I'm always excited to see stuff that she posts. And this is a very recent one. It's from June 9th, so just a couple of weeks ago. And I was excited to see this come out because it's one of these topics that data science is such a hot topic and has been now for so long, but there's so much focus on the machine learning that one thing that's really lacking is, okay, now I've got a model, it's been trained and it can do all this stuff.
Yeah.
How do people use it? Right. And so there's just not a lot out there. And so it was really cool to see she put together kind of an end-to-end article on creating a model, and then and how she did that, and then also getting it deployed so that anyone could consume it and use it. It's not a very technical article. There's not a lot of code in it, and which there didn't need to be. I mean, I think she took the right approach. There's so many articles to learn how to train a model. In fact, the example she gives, she uses a pre-trained PyTorch model to build something that she calls Venti, which is supposed to be a Medium-like blog site of like AI generated essays. So the Venti being the Italian word for medium. So it's a play on that. But this thing, she got a pre-trained PyTorch model from this group called Hugging Face, which I had never heard of, but they're an NLP group, and they have a bunch of pre-trained models that you can use to like sort of bootstrap a project and everything and get going quickly. And so she got this model, and then it's trained to make these essays. You give it like a phrase, and she gives it, for Venti specifically, it's like venture capitalist style like phrases. There's a pretty funny example here she gives of the kind of stuff that this Venti thing produces. And so she provided the model this phrase: "The startling thing is how often the founders themselves don't know. Half the founders I talk to don't know whether they're default alive or default dead." So whatever, some VC stuff. But this is like a real quote. Like she's saying, okay, she's giving this to the model, and then this is what comes back from the model. It starts with that quote that she gives it, and then this is how it continues. "The other half don't know what to do. The other half know what they should do and don't want to do. Those who don't know their own behavior are also often the ones who are the ones who are the ones who are the ones to do things the founders of all their companies." So it's just so just tying phrases together and producing some funny output. But she says, okay, so I've got this model, and I want people to be able to use it to provide their own phrases and have it generate some funny stuff. And how do I do that? And so a lot of data scientists have spent their careers learning things like Pandas and NumPy and working with data and plotting and visualizing and everything. And they're probably not super well versed in things like web servers and creating like a web application and all the HTML and the JavaScript and everything that you would need to host a model somewhere and make it consumable by someone, whether that's via an API or whether it's with like an actual front end user interface that someone can use. So what she decided to use, and I think it's a really cool tool, is something called Streamlit. And I think I had heard of it before, but I'd never really looked into it. So Streamlit is a framework that allows data scientists to build applications, web applications,
right,
extremely simply. I mean, it's it seems almost magical when you look at it. Like they give an example of you import Streamlit as ST, and you like there's a write method where it accepts a string that it looks like you can use Markdown
Okay.
in that string, and then it'll just render that as the correct HTML with the headings and the emphasis and the bold and everything that you want there. And then you can use like read a CSV file from like using Pandas into a data frame, and then pass the data frame to a line chart function on this Streamlit package, and it'll just generate a chart for you that and embed it in the application and everything. So it's like literally like 3 lines of code, and you can have a little hello world app with like a line chart and everything. Yeah, really, really cool. So she talks about how she used Streamlit and got this Venti thing up onto it, and some of the little things she had to do to get there, and things she was looking at, like using GPUs and that sort of stuff. So it covers a lot of different ground here. But yeah, it was just really cool to see this come out, this like end to end, like here's kind of a way you've got a model, you want to get it out, and here's an easy way to do that. So I hope to see more.
That's super cool.
There's not a lot of consensus really in the data science world of like what the best practices are for this, or like what there's just not a lot written out there on it. And there's even a couple quotes here. Like she says, there really is no good generalized single system of best practices for creating machine learning platforms. There's not even a textbook on it. She talks about the mystery of deploying machine learning. And she says, her experience has been that deploying a machine learning model is always much harder than building it or reasoning about the technical, mathematical parts of the model, and that there's not a lot of literature about the specifics of getting it into production. So again, there's a lack of guidance and best practices. And I was excited to see her put this out there and try to start filling in the gap there.
Yeah, this looks like a really nice tool for ways to share what you're doing, and then also get other people to be able to interact with it that are maybe not programmers. That Streamlit looks really, really cool.
Yeah, it does.
I'm very intrigued by that. So nice. What we were going to do this week, it's a little different, is kind of build on top of the articles that we were talking about. And instead of like saying, hey, what we're excited about this week, is to share some projects that the listeners can check out and hopefully get their hands on and play a little bit with it. And so we both picked out a project each that give a chance for listeners to mess with the stuff. And so my first one is about genetic drawing, and it's a GitHub repository that has a genetic algorithm, sort of a toy project for doing drawing. And it's by a developer. Her name is Anastasia Opara. So this is something she did several years ago. And the idea with it is you're taking a photograph. In this case, it's based on sort of black and white. It's applying a technique to make it look like it's been painted. So it's got a set of brush strokes. And then the algorithm is going in and it's analyzing the photograph and then applying these brush strokes in multiple layers as it goes through. And the project's pretty neat. It's once you download the code, you're going to install a couple different things, but it runs in a Jupyter notebook, and you can kind of see it going through the stages of generating the different layers and doing the details to kind of create this image. And then on top of that, you can choose, how detailed you want to be. There's a way to apply a mask to say this area here, I want there to be much smaller brush strokes and much more detail. And so you can kind of do that just with sort of black and white and masking techniques or gradients kind of going between that. I think it's a neat project to kind of get into that. I like doing stuff with art and doing stuff with photography, especially.
Yeah.
And so I like this idea of generative drawings that are kind of coming from it. And her website is really fascinating. She's definitely gone way further beyond that and into a lot of other open source tools for doing, as she calls it, texture synthesis and remixing from a single example. And so I'll share that stuff. I think it's kind of neat. I mean, yes, there are plugins that are out there for things like Photoshop, but here you're going in with Python and kind of playing with the code and adjusting individual things like, okay, how should this brush stroke be done and what the sizes should be and how many passes should it take? And it's way more, detailed kind of control. Had fun playing with it.
Yeah, super cool.
What's your project?
The one I got getting back to, I guess, like science, and this one isn't space related, but yeah, I'm also a big fan of science, and I found this project that it looks like it's not that old, just a couple of months old, but it was released by IBM, and it's called, I believe you pronounce it, MicroscoPy.
I think so
maybe
too.
Microscopy. I'm
Yeah.
not sure, but
I think
probably Pi.
Yeah.
But it is an open source microscope that you can build using Lego bricks, some 3D printed parts, Arduino, and a Raspberry Pi. And this thing is super cool. There's a GIF going back to the soft and hard cheater of this thing opening up. So it's fully motorized when you get this whole thing built together. But there's this image of it like opening up in like almost like a transformer, like turning itself into this microscope. It just looks like really cool. So you can kind of like, it all folds down so you can like store it away, and then you can, I guess, push a button and it all comes up here. And this is not like toy microscope. I mean, it's pretty powerful what this thing can actually do. So I'll read off some of the key features here that they've put on the README on GitHub. So fully motorized, you can adjust the camera angle, sample position, magnification, focus, and everything. They're all precisely tuned using 6-step motors. It's modular, so you can sort of reconfigure it, and it has different configurations that you can set up. It's versatile. It's got some built-in illumination for higher quality imaging.
So like LEDs and stuff that shine down.
Yeah, exactly. It says it's got a wide magnification range, so you can look at samples with features from several centimeters to several micrometers.
Okay. So macro and micro kind of stuff.
Yeah, exactly. It's quote unquote low cost. So it says the whole assembly costs anywhere from $200 to $400, which, I mean, is probably that's not super low cost, but it is, relatively speaking. I mean, for a comparable microscope, probably, I would imagine you're looking at over $1,000 easily for something that does.
Partly because of the fact that it isn't just like you're looking through it. It's a camera, and it's outputting actual digital signal, like
yes,
over HDMI. Is that right?
That's what it looks like. It's let's see. So the microscope uses a Raspberry Pi mini computer with an 8 megapixel camera to capture images and videos. It's got stepper motors, and the illumination are controlled using a circuit board comprising an Arduino microcontroller, 6 stepper motor drivers, and a high power LED driver.
Cool.
All functions can be controlled from a keyboard connected to the Raspberry Pi or a separate custom Arduino joystick connected to the mini board. Lego bricks are used to construct the main body of the microscope and achieve a modular and easy to assemble design concept. And then, you can connect an HDMI display, so you can see what the microscope is looking at. Yeah, I mean, overall, it's just really cool that, for a few $100s, if you've ever wanted to have like a powerful microscope.
Yeah. Just the photography end of it would be fun for me. Yeah.
Yeah. And you have access to a 3D printer, then, I mean, Arduino, Raspberry Pi is not that expensive. Lego brick you can get pretty cheaply, actually, from Lego themselves, or even third party there's a bricklink.com.
Right.
Is a good place to get used Lego parts. Yeah, so it's just I just thought this was just a really cool project, and I would love to try to build this one day.
Yeah, that sounds like a fun, maybe weekend long project, maybe longer, who knows.
Yeah, maybe longer.
Yeah.
And so all the code for the Raspberry Pi is all in Python, and then for the Arduino it's all in C++, but and it's all open source. You can see how they do it and try to modify it and make improvements, or maybe add functionality. So yeah, super cool.
Sweet. Thanks, David, for coming on the show again, sharing all these articles with me.
Yeah, thanks for having me. It's fun.
All right. Talk to you soon.
Yeah, take care.
I want to thank David Amos for coming on the show this week and bringing along all those great articles. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.